This video is to address week number 5, task number 8. In task number 8, it asks us to use our three-dimensional kit, which again, I am using GeoGebra, to graph the planes x minus y equals 0 and 2y minus z equals -1. Then we are to use both of these planes and determine whether or not line B exists, and if it does exist by the intersection of both planes, describe line B, including any of its intercepts. So what we can see here is that we have planes x minus y equals 0 graph, that's in blue. And then the other plane, 2y minus z equals -1, that is the plane that is in pink. And I think that it's interesting to note that the blue graph is, again, more simply put, is the y equals x plane. So again, it is diagonally cutting through the octants in 4 of the octants and leaving 4 of the other octants untouched. The plane 2y minus z equals -1, if we were to go ahead and isolate that down as we have in all of the other tasks into a y equation, it would read y equals 1/2 z minus 1/2. But we can again manipulate this algebraically, and we can actually solve for z instead. This will help us in a future task. But if we were to isolate z, our plane equation would become z equals 2y plus 1. But in the previous plane, we saw that y equaled x. So if they're simultaneously intersecting, then any property from the first is going to have a shared concept with the second. So if y is equal to x, then we also know that we can replace the y with x, and we can actually call this pink plane z equals 2x plus 1. I thought that was interesting, and it will help us in one of our future tasks. What we are to determine is whether or not line B exists, and I'm going to go ahead and say yes, it does exist. We can clearly see that the blue and pink planes, which are the two planes that are represented in this task, are intersecting. And furthermore, we can tell that they are intersecting because there is an intercept that both of them share. The intercept in question is 0, 0, 1, and that has an x value of 0, a y value of 0, and a z value of 1. That's because whenever you isolate the y, isolate the x, or you figure out x and y intercepts, they're going to share the exact same value because y equals x. So the only time that you're going to see an intercept occur with a value other than 0, 0 would be when you add that z in, and that comes from the pink plane. So we are again seeing, and we can see the point right there. My cursor is showing that the intersection is 0, 0, 1. Okay, so that is task number 8. Again, line B does exist.